Hello students, how are you all? Staying healthy and energetic? Welcome to an interesting topic of today's session, energy and different forms of energy. All of you want to be energetic, right? You go to gym, work out and try to stay fit and energetic. What's the meaning of energy in physics? As you know, energy is the ability to do work, ability to do or perform some amount of work. You can measure your energy in terms of your work done. Work done and energy both are same. When you are doing certain amount of work, equal amount of energy is consumed. Energy is a scalar quantity and its SI unit is joule. Work is also having the same unit, that is joule. Today we have to learn about different forms of energy. In mechanics, an object has two states. It can be either in the state of rest or it can be in the state of motion. Alright? So the energy possessed by a body due to its state of rest or due to its state of motion, we call it as its mechanical energy. Mechanical energy. So the mechanical energy has got two forms, that is potential energy PE, kinetic energy KE. Or we can say that whether the body is at the state of rest or in the state of motion, together we call it as mechanical energy. So the mechanical energy is sum total of its potential energy U. Potential energy is denoted by a letter U and kinetic energy K. So we can say mechanical energy is sum of its potential energy and kinetic energy. Alright? Okay. So what is potential energy? Potential energy U. The energy possessed by a body due to its position or due to the state of rest. You can see that this body is waiting here. Due to its state of rest and shape, we call it as the potential energy. Okay. For example, a car resting on the ground, a bent bow, a stretched rubber band. A stretched rubber band, you can see a stretched rubber band has potential energy. And a body sitting on the top of a mountain. So I have kept this car on the top of or at a certain height. Now this car has potential energy because it has changed its position. This rubber band, now it is in the original shape. When I stretch it, its size and shape changes. You can see. Now due to the change in size and shape, it has potential energy. Alright? So a stretched rubber band has potential energy. A body kept at certain height has potential energy. A body in waiting or a body at rest has got potential energy. Okay? Yes. Then what is kinetic energy? Kinetic energy is the energy possessed by a body by virtue of its motion. See, a moving body has kinetic energy. Now, this body is in motion. It has kinetic energy. Other examples, a speeding car, a speeding train, a running boy, flowing water, blowing wind, everything has kinetic energy. Alright? So these are the kinetic energy and potential energy are the different forms of mechanical energy. Mechanical energy is equal to sum of potential energy and kinetic energy. In mechanics, the potential energy is of two types: elastic potential energy and gravitational potential energy. Potential energy is of two types: elastic potential energy and gravitational potential energy. Let's check it out. What is elastic potential energy? You can see a rubber band here. So the energy possessed by a body when it is in the deformed state due to its change in its size and shape, we call it as elastic potential energy. So it's a rubber band. I am trying to stretch this rubber band, applying some force. Now the rubber band has got deformed. It has changed its size and shape. So on the removal of the force, I am applying some external force to change its shape. On the removal of the force, what happens? We can see. Now it is stretched state. On the removal of the force, it came back to its original, it regained its original form due to the property of elasticity. So I am doing some work in deforming this rubber band, and this work done by me is getting stored in this body as elastic potential energy, because my work done has changed its size and shape, and this work done is stored in the body as elastic potential energy. So a stretched rubber band has got elastic potential energy. Alright? Okay. Now, what is gravitational potential energy? Gravitational potential energy is nothing but it is energy possessed by a body due to its force of attraction of the earth. So every body, when it is resting on the ground, it is attracted towards the center of the earth with an invisible force. We call it as gravitational force. So due to the attraction of the earth, a body has potential energy. So the potential energy, gravitational potential energy of a body is assumed to be zero. Assumed to be zero when it is resting on the ground. So U is 0 here. As it goes up, what happens? As it gains height, the gravitational potential energy increases. Now this car was lying on the surface of the earth. It has gravitational potential energy 0. I am keeping the car at a certain height. It gained height, and now this car possesses, or this object possesses, gravitational potential energy. Because how it possesses gravitational potential energy? Because I am lifting this body up. While I am lifting up, I am doing certain amount of work against the force of gravity. You have to overcome the force of gravity. It will not come up naturally. So in order to overcome the force of gravity, I have to do certain amount of work. I have to apply force. I am doing certain amount of work. So I am, as the height increases, I am doing more and more work. And when I kept this body over here, I have done certain amount of work on the body against the force of gravity, and this work done by me is stored in this body as gravitational potential energy. Now this body has gravitational potential energy because it has changed its position from the ground. Now it has reached at a certain height. Okay, so since work is done by the force of gravity itself, so at a finite distance, see, if you are going higher and higher, the force of gravity going on decreasing. The force of attraction of the earth decreases and this gravitational potential energy increases. So if you are going higher and higher, at a particular point, the gravitational force of attraction of the earth decreases and the gravitational potential energy increases. So energy decreases, finally it becomes 0 at infinite separation. So if you are going very far away from the earth's surface, so finally the gravitational potential energy becomes 0 at infinite separation. Remember that. So when a body gains height, the gravitational force of attraction decreases and the gravitational potential energy increases, and finally it becomes 0 at infinite separation. Remember this point. So the gravitational potential energy is nothing but it is the amount of work done in bringing a body from one point to that point, a particular point. Clear? Is it clear to you? Now let's investigate what is kinetic energy and what is potential energy, how potential energy is getting converted into kinetic energy with a simple activity. Let us see the effect of potential energy and gravitational kinetic energy. Okay, ready for the activity? Alright, let us perform the activity. As you know, a body is in the state of rest, has potential energy, and a body in the state of motion has kinetic energy. Let us see how this potential energy is getting converted into kinetic energy. Remember children, potential energy, we cannot put potential energy into any uses directly. Potential energy should be first converted into kinetic energy, then we can use this kinetic energy to any form of energy, or a kinetic energy can be converted into any form of energy. The potential energy must be converted into kinetic energy, and this kinetic energy can be put into any other useful form of energy. Remember this point. Okay, let us investigate. What I am doing here, this is a body at rest. I am trying to impart some potential energy to a body by keeping it over the certain height. Can you see? Okay. I am keeping this body on a ramp, on an inclined surface, such that it has changed its position. It has gone up to this height. Now I have imparted some potential energy to this body. An object is kept over here at a marked place. If I leave this body, what happens? The potential energy gradually is getting converted into kinetic energy. Now the body is at rest now. Now if I leave this body, the body is set in motion, its potential energy is getting converted into kinetic energy, and kinetic energy will do certain amount of work by pushing this object further away. Let us see what happens. Okay, it has pushed further away. It is gone out of this board. We cannot notice it. So it has done much amount of work. See, the potential energy is getting converted into kinetic energy while the body is rolling down the inclined plane or the ramp, and it is doing certain amount of work by pushing this object further away. Look at this activity. Very simple activity which you can perform at your house. See. All right? Okay. Now, this was a heavy object. Now I am taking a light object. I have chosen a lighter car, a blue car, which is very light in weight. Let us see what happens as the mass increases. What is the changes seen in energy? Let us see. The same height, remember that the same height, have not done anything with the height. The object is here, the same object is here. What happens when I release a lighter car? What happens to the energy? Let us see. See, it has pushed this object up to here. Okay, you can see it has brought this object up to this much point. This is the distance, displacement, or the work done by this body. In the previous case, we have seen that it was pushed off. It was going out of this board. That means this is a heavy body. It possesses more energy. It can do more amount of work. And this is a lighter body. The mass is less. It can perform less amount of work. All right. See. Once again, let us see. Very simple activity. See. It has reached up to this point. Then what about this car, whose mass is greater? See, it will go beyond the board. See, it has gone out of the camera. All right. So it can perform a lot of work because its mass is more. All right. Now what I am going to do, I am going to increase the height by keeping one more book, the Joy Luck Club. All right. So keep reading. Keep reading books. So I have increased the height of this ramp. So let us see what is the effect of height. We have seen the effect of mass on the energy produced, on the work done. Now let us see what is the effect of height on the position of energy. Okay, let's see. I am using the blue car, which is a lighter one. I am keeping it here. From here, it was a park. It was waiting. The potential energy 0. I kept this body. I tried to impart some potential energy by keeping it at a height. Now the body has potential energy. Now when I release it, the potential energy is getting gradually converted into kinetic energy, and this kinetic energy can perform certain amount of work done. Let us see how much work it can do. See, again it has reached up to here. See the body is here. The first was A1, now it has reached A2. It has pushed further away to a more distance. You can see the displacement. More the displacement, the more amount of work is done. So as the height increases, what we saw, as the height increases, the energy, potential energy increases. The increment in potential energy is reflected in kinetic energy and work done. Of course, when the potential energy increases, kinetic energy increases. More the kinetic energy, more will be the work done. See, it has gone out. Okay, farther away. All right. Okay. Now what about this body? So you cannot even see in the camera, right? Keeping it here. It's a heavy body. So mass also increasing, height is also increasing. Of course, it can perform much more work than this lighter one. Let us see. Oh, it has gone out. It has gone out of this board, out of the focus of the camera. So this body has more mass, and when it gained more height, it can perform lot of work. All right. So this way, the potential energy is getting converted into kinetic energy, and you have seen through the activity how the energy is getting converted from potential to kinetic, and it again how the height and mass brings about changes in kinetic energy and potential energy. All right. The investigation is interesting. You can perform at home, and you can see the difference in energy because of increase in height and increase in mass. Okay. So children, we have learned about kinetic energy and potential energy through an activity. We could understand more because physics is such a subject which needs thorough understanding, conceptual clarity, a deeper understanding. You cannot mug up anything in physics. If you try to mug up, you are doing a big mistake. Physics will be too boring and a Herculean task for you. I will try to make physics learning as interesting as possible by incorporating some activities into the topic. Okay. So we have seen what is kinetic energy and what is potential energy. Now, how can you measure this potential energy and kinetic energy? We cannot measure directly in energy. We can measure the energy in terms of work done. Now let us study how the potential energy is measured. Measurement of potential energy. Let us consider a body of mass m resting on the ground. It is lifted from A to B through a vertical height of h. Okay, a body of mass m resting on the ground at the point A, it is lifted vertically upward through a height h as seen in the figure. All right. So what is potential energy? So the potential energy is nothing but it is the work done. You cannot measure potential energy, right? It can only be measured in terms of work done. So U is equal to W is equal to, what is the formula for work done? Force into displacement. Here the displacement, here what is the displacement? It is equal to h from A to B through vertical displacement. And what is force? What is the force? Force acting on this body, F is equal to mg, that is the gravitational pull which is directed towards the center of the earth. So I can write U is equal to W. F is substituted by mg, F is equal to mg, and S is equal to h. So we are getting U. Potential energy is nothing but it is the amount of work done in lifting a body through a height h, vertical height h. So mgh, U is equal to mgh, where m is the mass of the body, g is the value of acceleration due to gravity, and h is the vertical distance or the displacement. So the gravitational potential energy is equal to mgh. Precisely, mgh is nothing but it is the gaining potential energy of the body when it is raised from one point to another point. Suppose we have a body of mass m. Okay, I have body of mass m here at a height h1, and it is being lifted through a height h2. Can you see? Okay, it is lifted to a height h2. Body is at the point initially at a at a height h1. Now it is vertically lifted through a height h2. Now the body is at b. All right. Yes. Then what is the gain in potential energy? The body is gaining. There is a gain in height, so it is going up, right? So there is a gain in potential energy. What is the gain in potential energy? Gain in potential energy. How much? Gain in potential energy is equal to the difference in potential energy, right? The final potential energy, I can write UF minus UI. The final potential energy minus the initial potential energy. What is the final potential energy? I can write UF is equal to, mass remains same, G remains same, the height changes, mgh2. Alright. So what is the initial kinetic energy? UI, mass remains same, G remains same, the height is h1. So I can write UF minus UI, difference in or gain in potential energy is equal to mgh2 minus mgh1. Alright. So I can write the final potential energy or the gain in potential energy, gain in PE is equal to mg common outside h2 minus h1. Alright. So this is the gain in potential energy. So numericals are asked based on this. So gain in potential energy is equal to mg into difference in height h2 minus h1. Remember this formula. Okay. Very good. Now the next form of energy is to be measured is kinetic energy. The measurement of kinetic energy. So we have learned about kinetic energy, then we should know how to measure it using a formula. Of course, we devise formula in physics. We derive formulas for measuring a physical quantity. So let us see how kinetic energy is measured. You know that kinetic energy is the energy possessed by a body in motion. A body in motion possesses kinetic energy. So this moving body can perform certain amount of work. So you cannot measure the kinetic energy directly. You can measure the energy in terms of the work performed by this body before it is coming to rest. So now I have, so body is moving, kinetic energy. Now I have stopped the body by applying an opposing force in the opposite direction. So it has done certain amount of work before coming to rest. So by measuring the work done by the body before coming to rest can be expressed as kinetic energy. Okay, let us, based on this concept, let us try to derive an expression for kinetic energy. Suppose we have a body of mass m, our car, okay, moving with a velocity, it is already in motion. It is a body of mass m, it is already in motion, okay, moving with a velocity v. Now I have applied some opposing force here. So the body came up to here. I have applied some opposing force opposite to the direction of the motion, constant opposing force F, and body came to rest. It has got displaced through a displacement S. Okay, see, body was moving, I applied some force and it came to rest. Okay, through a displacement S, and such that I have applied an opposing force F. So when you apply an opposing force, so the body is being retarded, right? Its motion is stopped. So producing a retardation or negative acceleration A. Okay, let A be the uniform retardation produced there. Okay, and now what will be the magnitude of retarding force? The mass will be m, of course, mass will not change. What is the retarding force here? Retarding force I can write as F is equal to mass into retardation. Alright. Okay, this is equation number 1. Okay, so we got the retardation. So what is kinetic energy? Kinetic energy is nothing but it is the work done by the retarding force in the displacement of S before it is coming to rest. So I can write kinetic energy is nothing but it is the work done. Work done. We can measure kinetic energy in terms of work done. So I can write kinetic energy K is equal to W, work done. Work done is equal to force into displacement. Force into displacement. Equation number 2. Okay, up to here. Clear? So we have F. We got F is equal to ma. The displacement. We don't know what is displacement. We have to find out an expression for displacement, right? Because velocity is changing here. So to calculate displacement, we have to take the help of equation of motion, which you have studied in grade 9. So I can write the initial velocity. Initial velocity u is equal to v. Initial velocity v. And what is the final velocity? What is the final velocity? Final velocity v is equal to, so it came to rest. The body came to rest by an opposing force. I stopped the body. So the final velocity became 0. Alright? Yes. And the retardation, the acceleration or the retardation produced is minus a, because it is negative acceleration. Alright? Yes. Now we know the equation of motion as v square is equal to u square plus 2as. I hope all of you know this equation, where v is the final velocity, u is the initial velocity, a is the acceleration and displacement, giving the relationship between final velocity and displacement. Now let's substitute in this equation. Let's see v. What is v? V is equal to 0. 0 square is equal to u is equal to v. V square minus 2as. Displacement is s here. What is the displacement? S here. A is minus, so I have put the minus sign here. V square minus 2as. So just rearrange this. We can write v square is equal to 2as. Okay, I took v square here. V square is equal to 2as. So what we require? We need s, right? So we get s from this formula as v square by 2a. So we got displacement as v square by 2a. Now substitute the value of this s is equal to v square by 2a and f is equal to ma in equation number 2. So kinetic energy is equal to work done. That's equal to, what is f? F is equal to, we can write ma. Alright, what is f is equal to ma into, what is displacement? V square by 2a. Clear? Are you following? Can you get me? So just substitute the value. F is equal to ma and s is equal to v square by 2a in this equation number 2. A gets cancelled. Then what is left? Kinetic energy is equal to work done 1 by 2 mass into square of the velocity. We are getting it as kinetic energy K is equal to half mv squared. Very important equation. Kinetic energy is equal to half mv square. Potential energy is equal to mgh. These are the two important equations we learned today. So kinetic energy is equal to half mv square. So the kinetic half is a constant there. If you look at this equation, if you try to explain in terms of physics, kinetic energy directly proportional to mass of the body, kinetic energy directly proportional to square of the velocity. Alright, on doubling the mass, kinetic energy will be doubled. On doubling the speed of the body, the kinetic energy will become 4 times. So v squared, if you double it 2 squares, it will become 4 times. Alright, so in other words, I can say that a faster moving body has more kinetic energy than a slowly moving body of same mass, because see, the velocity is square of the velocity. So that's why I can say that a faster moving body has more kinetic energy than a slowly moving body of same mass. Kinetic energy is equal to half mv squared. Alright children, so we have learned about kinetic energy and potential energy through an activity, and we learned how to measure kinetic energy and potential energy using the formula. Alright, thank you.